Hello, this is Chandrasekhar M. I work as Associate Professor in the Department of Civil Engineering, Maharaja Institute of Technology, Mysore. So now, for this semester, I am going to take elements of civil engineering and mechanics subject. Hello, welcome to elements of civil engineering and mechanics class. In fact, that is elements of civil engineering and engineering mechanics. So this subject comes in first and second semester and it comes under physics cycle. Okay, a student has to study in only one semester. So physics cycle, chemistry cycle, the students who are studying in physics cycle are going to study this subject. Okay, when they go to the next semester, students will become chemistry cycle, and chemistry cycle students will become physics cycle students, and those students will study this subject under physics cycle in the second semester. So this subject is taught in both semesters only once. Okay, and this subject has 100 marks, of course. One is 40 marks for internal assessment and 60 in the semester end examination, and the number of classes is 3 hours per week and the examination hours is 3 hours, and it has 5 modules, and in the examination you will have to answer at least one question from each module, and total you will have to answer 5 questions, and all questions carry equal marks, and of course there will be subdivision in the questions. So to start with, what I do is I am going to cover the first module in this class, that is Introduction to Civil Engineering and Introduction to Engineering Mechanics part, and subsequently of course module 2, module 3, module 4 and module 5, those things come later. So coming to this elements of civil engineering and engineering mechanics, majority of this subject has engineering mechanics part, that is 4.5 modules. Only a tiny part of the total subject has elements of civil engineering. So that comes under the first module, that is Introduction to Civil Engineering, and the next part is Introduction to Engineering Mechanics. So under Introduction to Civil Engineering, we are going to study the scope of different fields of civil engineering, and also we are going to study the responsibility of a civil engineer in infrastructure development. So let me take up these things first. So that is Introduction to Civil Engineering, that is different fields of civil engineering and their scope. These are the different fields in civil engineering. If you go for higher studies, you can do specialization in one of those. To start with, structural engineering. So as fresh students, you don't know what is structural engineering. So let me give an example. If I take any building, that is a house for example, so structurally speaking, the house can be divided into 2 parts. One is that consists of several elements, and one is structural part and the other is non-structural part. What is structural part? The structural elements who carry load and finally transfer those loads to the foundation, those are structural parts, and non-structural parts are like doors, frames, etc. So under structural engineering, we are not going to worry about the non-structural part, we are going to worry about the structural part. Say for example, as I said, in a building we have several structural components. So what are those structural components? Slab on which you are going to stand, beams and pillars. From now on you are not going to call that as pillars, instead you are going to call those as columns as civil engineers. Then footing, etc. Those are all structural parts of a building. So how it works? So in structural engineering, what we do is, to start with, if I take the example of a slab, okay, the slab is subjected to different kinds of loads. We are going to divide those loads mainly into two parts. One is dead load and the other is live load. So what is dead load? It is the self weight of the slab, and whatever floor finish we give to the slab is dead load. So in general, dead load is a permanent load. And what is live load? The live load are variable loads which keep changing. Okay, we are live loads because we keep moving and we don't stay in one place, and on a given floor there will not be people always all the time. Sometimes there will be 10 people depending on the size. Sometimes there will be no people. Okay, so what we do is, by considering all the worst possible scenario as far as load is concerned, we are going to take that load and including the self weight of the slab itself. Okay, using that load, what we do, we are going to find out what are the moments, shear forces for that particular structure at different sections, and to take care of those loads, we are going to provide adequate depth of the slab and reinforcement. What kind of reinforcement? What are the diameter of the bars? What are the spacings of the bars? So all those things we do, that comes under structural engineering. Okay. Next comes the beam. Whatever load coming on this slab is going to be transferred to the foundation finally. So how it gets transferred? From the slab to the beams, beams to the columns, columns to the footing, then footing to the foundation. Okay. So once the loads get transferred, so each beam, if I take beam, next if I take column, so each will be carrying different kinds of loads, different magnitudes of load, and the process which we are going to find out all those forces coming on those structural elements is called analysis. That is called structural analysis. So first we do structural analysis, then we are going to go for design. Design is nothing but finding out what are the dimensions of those structural elements required and what are the reinforcements we need to put. Okay, what are the sizes of beams, what are the sizes of slabs, what are the sizes of columns, what are the sizes of footings, etc. Okay, those things come under analysis and design. Okay, again I repeat, structural engineering has two parts. One is analysis part and the other is design part. I hope this is clear. This is for a simple building, and the same concept applies for any multi-storied building. It may be 10-story building, 20-story building, basic concept is the same. Even if you take a bridge, for example, that comes under structural engineering, that is design of bridges. There also we are going to consider the load. What are the kinds of loads we are going to consider? Dead load and live load. What are the dead loads? Dead loads are the permanent loads, like self weight of the structural components or bridge elements and the road surfaces. What are the live loads? Vehicle loads. So vehicle loads are the live loads coming on a bridge. Okay, including the impact effect we are going to take into consideration, because the loads will be moving and we apply brake and we accelerate a vehicle. Those things are going to create additional stresses within the material of the bridge. Okay, so this whatever I have explained is just a summary of the scope of this branch, structural engineering. Okay, it is a huge field and it is interesting, and I hope you are going to develop interest in this field and you are going to go for higher studies under this specialization. Next, the number 2 is geotechnical engineering. Another name for geotechnical engineering is soil mechanics. So I said finally all loads get transferred to the soil. See, when we transfer the load to the soil, we have to make sure that whatever the load gets transferred is safely carried by the soil. Okay, accordingly we are going to distribute the load through the footing to the soil, so that soil will not fail, or the soil will safely carry the load coming on this without much differential settlement or without much settlement. Okay, so that's what we do in soil mechanics or geotechnical engineering. So what we do in geotechnical engineering basically, so here first we need to find out what is the safe bearing capacity of the soil. Again, I am taking an example of a simple building, that is called SBC, safe bearing capacity. So to find safe bearing capacity, so we need to find, or we need to determine different properties of the soil. So the different properties of the soil are physical properties and also engineering properties. So engineering properties are useful in finding out the bearing capacity of any given soil. Okay, even if you take soil, the same, it will have different kinds of soils when you go to different places, and also when you go to different depths, and they will have different bearing capacity values. So what we do is, whenever we construct a structure, the first thing we are going to do is do soil testing. So how do we do soil test? We collect the sample, we are going to study different properties of that soil. So there are different properties. Finally, we are going to find out what is the safe bearing capacity of the soil, so that we can stretch the soil within certain limits under external load. So there are different properties like, cohesive property, internal friction property, and also we are going to study grain size distribution of the soil. Grain size distribution is nothing but a soil contains different soil particles of different sizes, and those different sizes, if you take any size between specific sizes, say for example soil of between 200 micron and 600, 300 micron and 600 micron. So between that you will have certain quantity of soil per unit weight of soil. Okay, similarly for different sizes. So that is called grain size distribution. So those grain size distribution affects the safe bearing capacity of the soil and also settlement of the soil. Okay, not only that, if a given soil is very soft and if we have to build a structure, then what we do is we are going to treat the soil, or we are going to strengthen the soil to take care of the load coming on it in the lifetime of the structure. Okay, and these are the few things we do, these are the basic things we do, but it has got wide scope. Similarly, there is another branch or another field of civil engineering is environmental engineering. So you must have heard what is environmental. So it is very familiar. We always talk about environmental pollution. So initially when they started environmental engineering, there was no concept of pollution and all those things, not to a great extent. So environmental, we always thought about water supply and sanitary. That is providing water supply for drinking and other purposes, and sanitary, whatever drinking water provided, so is going to be treated and it is going to be disposed of finally. So there are two stages. So treatment, how it is done for a given city, if you are supplying water for a given population, so how much water we need, so where to get the water from, whether the water is available in that source. So all those things we study under water supply. And under sanitary, what we do is, once the water goes off as sanitary water, so that has to be treated, because we cannot dispose that water directly into any river or into any place before treating, otherwise it is going to pollute the environment. So it has to be treated to some extent so that it can be discharged into any water body, so that the water body does not get contaminated. Okay, those are the two basic things, but now it goes beyond that nowadays because of increase in population. So resource for human beings increased. So that led to environmental pollution. What are the environmental pollution? Air pollution, noise pollution, so water pollution and all those things. So then how to measure all those things and also how to take care of those things so that human lives are not affected. So those things we are going to study under environmental engineering. Next, coming to water resources and irrigation engineering. Water resources and irrigation. So we know we need water to grow any crop, any vegetables, etc. For that we need water. So what are the resources for the water? So in some place it used to be in India, majority of the population was depending on rainfall. Even now it is so. And also we are depending on the water supplied from dams. So again underground water. So then we are going to irrigate the land using those water supplied from the dams. In this subject, when we say water resources and irrigation engineering, what we do is, so we are going to study about the rainfall, we are going to study about the pattern of the rainfall, how much water we are going to get, what is the catchment area, if you are constructing a dam, so what is the catchment area which is feeding that particular reservoir, so that we can know the capacity of the reservoir. Depending on the capacity of the reservoir, we can decide how much land can be irrigated and also how much water can be provided for drinking purpose. So all those estimations are done. So that is done under water resources and irrigation engineering. Next comes transportation engineering. Transportation means trans plus port. So port is carrying, trans is across. So carrying across. That was the way that word transportation started. Transport started. Now transportation is used just carrying something. Something, it may be human beings or some goods from one place to another. That is transportation. So there are different modes of transportation. So what are the different modes of transportation? Land, air and the sea. When it comes to the land, further roads and railways. Okay, and similarly we are going to study again subdivision, road, national highway, state highway, major district road, minor district road, village roads, etc. So those are, and how to construct those roads. So what are the requirements for those roads? So national highway, what are the dimensions of the roads we need for national highway, for state highways, for major district roads, everything. Those are all specified by IRC, that is Indian Roads Congress. We are going to follow the codes provided by the Indian Roads Congress to fix all those things. Okay, and also before constructing any roads, we need to conduct survey. So we are going to do that, and this subject, that is transportation engineering, covers all those things. Okay, next comes hydraulics. Hydraulics means it is nothing but water. So what is hydraulics? We are going to study the behavior of water when it is standing and also when it is moving. Okay, that's what we do under hydraulics. So it is an interesting subject and interesting specialization. So we are going to apply different Bernoulli's equations, basically that is the one, and Pascal's law. So all those things we are going to make use of to study the behavior of water, and we are going to study that part under hydraulics. Again, when it comes to surveying, yes, when you say surveying, we always think about the measurement. Of course that is true, but that covers only a limited part of surveying. So mainly we are going to divide the surveying into two parts. One is plane surveying and the other is geodetic surveying. So what is plane surveying? Earth is round, it is not flat. Okay, up to 2060 square kilometers, we are going to assume the earth as flat. That means we are going to ignore the curvature of the earth when we are doing survey up to that area. That is up to 260 square kilometer area. Okay. Beyond that, yes, we have to consider the earth's curvature. Okay. Under surveying, what we do? So again, plane surveying, we are going to make use of different instruments to do surveying, like chain, tape, theodolite, dumpy level, compass to measure angles, theodolites to measure again angles, and also to calculate the altitudes and distance between two inaccessible points, to find out the distance between two inaccessible points, etc. And when it comes to geodetic surveying, where we consider the curvature of the earth, so we are going to go for advanced surveying. Even now we are going to do survey using satellites, aeroplanes, etc. Coming to building materials, yes. So to construct a building, yes, all of you know we need different materials: bricks, cement, if I take a simple structure, then steel, etc. If I take bricks, for example, so what is a brick consists of? So it consists of just the soil, not simply any soil, but the soil which has to be of containing grains of some specific size. And we are going to take that, we are going to mix it with water, and we are going to put them in mold, and once that is dried, then we are going to burn it to make it a hard material. Okay, we are going to study the properties of the materials used for the bricks, and also once a brick is made, we are going to study the properties, physical properties, and also the engineering properties of those bricks. That means those bricks have to satisfy certain conditions, like it has to have certain crushing strength. We are going to do crushing strength test by applying load on the bricks. Okay, and we are going to decide whether that is suitable, that brick is suitable to be used as a building material or not. Okay, then we are going to conduct absorption test, sound test. So different tests we are going to conduct on that particular brick, just for brick alone. So coming to other things, for example, concrete. Again, that is also building material. So concrete consists of coarse aggregate. What is coarse aggregate? Coarse aggregate, you popularly call it as jelly. Fine aggregate, that is sand, and the binding material, that is cement, and of course water. So we are going to study how to manufacture cement, what are the different kinds of cements, so what are the different properties of cement, and what are the properties the cement has to satisfy. That is, we are going to test the cement, and we are going to find out different properties, and they have those values after testing has to come within certain limits. So for example, if I take cement, we are going to conduct initial setting time test, final setting time test, then we are going to find out the soundness of test, find out the soundness of cement, then crushing strength of cement, that is compressive strength of cement, etc. So Indian Standard Code has given certain specification on how to conduct all these tests, and also they have given the values which the cement we are testing should satisfy. Okay, once that is satisfied, then that particular cement is fit to be used as a construction material. Otherwise, we are going to ignore or we are going to reject that sample. Okay, and also we are going to study how cement is manufactured, what are the compounds and ingredients of raw material, what are the raw material ingredients we are going to use to manufacture cement. Okay, that is cement. When it comes to fine aggregate, Yes, the best fine aggregate is river sand. So it will not be having any salt content because we are not using any ocean sand. Okay, we are not supposed to use the ocean sand. Only river sand is ideal. But nowadays, because of the lack of ocean sand availability, we are going to go for M sand, that is manufactured sand. We are going to crush the rocks into smaller grains, and we are using those things as fine aggregate. And coarse aggregate, yes, crushing the rocks to the required size, and we are going to use that material as cement, concrete material, one of the ingredients of concrete. Next, coming to the steel, of course, that is manufactured in factories, so they will have good quality, and we have different grades of steel. So what are the different grades of steel? You must have heard TMT 500, TMT 550 on buses. They give advertisement. So of course we have FE 415 steel, FE 500 steel. So FE 415 means that is the ultimate tensile strength of the steel, 415. So that is 415 Newton per millimeter square. So that is the ultimate characteristic strength of the steel material. Okay. So once we get that material, before use that particular steel, because that is manufactured by different manufacturers. So when we test it, so the strength should be at least 450 Newton per millimeter square. So it is not the test is done, but when it comes to finalizing the strength, it is not as simple as I am saying now. So actually 450 Newton per millimeter square is characteristic tensile strength. I have to use characteristic. Okay. So that is the steel, and also we are going to conduct different tests on the steel to find out that compression test, tension test, torsion test, etc. Okay. Similarly, even for coarse aggregate, that is for jelly, we are going to conduct different tests, crushing test, okay, then water absorption test, flakiness index and elongation index test, etc. Those are all the tests we conduct once you join civil engineering field, once you start studying. So you are going to study and you are going to do all these things under this subject. Okay. So building materials I covered, cement, steel I covered, then bricks I covered. Okay. So what are the other things? Wood is also a material we are going to make use of in buildings, that is for windows, then doors, etc. So again tiles, granites, okay, those are all building materials. So we are going to study those things in detail under this subject. Next comes construction technology. Yes, once a plan is prepared for any project, it may be a building or it may be a brick project worth thousands of crores. It may be a harbor, it may be a long road, 100-kilometer road, 200-kilometer road, or even 1000-kilometer road, national highway, state highway, etc. What we do is, first for all survey, estimation, if everything is done, before we execute the work, so everything should be ready, plan should be ready, everything should be ready. Afterwards, we start executing the work after doing all those plannings. Different plannings are done. So we are going to cover that under construction technology. So and also this construction technology deals with the materials as well. Okay. So these are the different branches or different subjects under civil engineering, and you can do specialization in any one of these subjects when you go for master degree level. Okay, I hope you are going to try for that and you are going to improve your knowledge, and so based on your interest among this. Next comes, what is the role of a civil engineer in infrastructure development? So what is infrastructure, by the way? See, if you are building a big city, say for example, if I take Bangalore or Mysore, so to attract people to live, to do business, so infrastructure should be ready. So what is the meaning of infrastructure? What are those infrastructure? Roads, other communications, water supply, electricity. So all those things should be there. Only then we can attract people for business and also to live in that particular city. So in the development of these infrastructures, civil engineers play major role. Almost, you take any infrastructure project. So participation of civil engineers is a must. Construction of roads, construction of buildings, construction of bridges, construction of this one, water supply lines, water treatment plants, design of construction of sewage treatment plant, etc. So that is very important. Civil engineers play a very important role every day in human lives. So we cannot survive without civil engineers. So civil engineers are the top priority for human beings. Thank you. And I am going to continue with the next part, that is Introduction to Engineering Mechanics, in the next class. Thank you.